Hey, welcome back. Now that we're experts at creating a perfect square trinomial, we're going to use it inside the process called completing the square. And we're going to solve quadratics. This is like this is our final method of solving. And also we're going to use it to help us write a quadratic in what's called standard form, which is kind of an easy way to graph. So we're going to do that tomorrow. So the first thing that we have to do is take the constant as it is and move it to the right. So that just means adding 5 to both sides. And when I do that, I create kind of a gap right there. And now remember our technique of creating a perfect square trinomial? That's step 2. We're going to take half of b, which is 4 over 2, which is 2. We've done this in the previous video, and we're going to square it and we're going to add it to both sides. So we have x squared plus 4x plus 4 equals 5 plus 4. Whatever I do to the left side, I have to do to the right side. That keeps my equation balanced. We learned that we just created a perfect square trinomial, so now we're going to factor it into x plus 2 squared. And then we're going to add these two numbers together on the right. Sometimes we're going to get fractions, and it's going to be okay. We're going to keep it in fraction form. Then we're going to apply the square root property. We're going to take the square root of x plus 2 squared, and we're going to take the square root of 9. Again, whatever I do to the left side, I must also do to the right side. Whenever I have the square root of something being squared, these cancel each other out, so I'm left with whatever the radicand is. That's the expression under the radical. Whenever I take the square root of the right-hand side, I'm going to put a plus or minus on there. It's looking easier now, right? So now I'm going to subtract 2 for both sides, so I get x is equal to negative 2 plus or minus 3. This is just a condensed version of writing the expression, but you get two equations. X equals negative 2 minus 3. So I'm going to write that. X equals negative 2 minus 3. And I also get the expression x equals negative 2 plus 3. X equals negative 2 plus 3. Now I'm going to combine those numbers and write it as an ordered pair. Negative 5, 0 and positive 1, 0. And that's it. Let's try it one more time. We're given a quadratic. We're solving by completing the square. So you're going to start by moving your constant, that's c, to the right. So we get x squared plus 12x is equal to 13. Now I'm going to make a perfect square trinomial on this side, the left, by taking half of b, 12 divided by 2 is 6, and I'm squaring it, and I'm adding it to both sides. So 6 squared is equal to 36, so I get x squared plus 12x plus 36 is equal to 13 plus 36. Ooh, that's tight. As I would say, that looks crumbly. X squared plus 12x plus 36 equals 13 plus 36, right? The left side is now a perfect square trinomial that factors. We made it so it factors really easy. It's going to be x plus 6 squared, and then we're going to add these two numbers together and we get 49. Now we're going to use our square root property, and we're going to take the square root of both sides. Whenever we have the square root of something being squared, these undo each other. So I get x plus 6 is equal to plus or minus the square root of 49 is 7. So now I'm going to solve by moving my 6 over, subtracting 6 from both sides. So I get x is equal to negative 6 plus or minus 7. Notice that I always write this in the front. Just kind of helps the process flow easier. So that means I get x is equal to negative 6 plus 7, and x is equal to negative 6 minus 7. So I get x is equal to, when I add those together, I'm just going to go straight to ordered pair because I'm running out of space here. So when I add those together, I get 1, 0. And when I add these together, I get negative 13, 0. Those are my two solutions. We're going to write real solutions, including ones that have radicals, as ordered pairs. We're going to write complex solutions just as x equals, all right? We're going to try one more. We're going to move that 31 to the right. So I get x squared minus 11x is equal to negative 31. I'm going to take half of b, which is negative 11 divided by 2, and I'm going to square it, and I'm going to add it to both sides. So that's 121 over 4. So I'm going to go x squared minus 11x plus 121 over 4 equals negative 31 plus 121 over 4. I'm going to factor the left-hand side because I've created a perfect square trinomial. And this gives me x minus 11 halves squared. And now I'm going to combine these two. Negative 31 is equivalent to negative 124 over 4. I just did it very quickly by multiplying negative 31 times 4 and then putting it over 4. That's how you make a fraction out of a whole number very quickly. And then I have plus 121 over 4. So now I have x minus 11 halves squared equals negative 3/4. So now when we take the square root, we're going to have a negative under our radical sign. So I'm going to take the square root, and I get x minus 11 halves squared is equal to the square root of negative 3/4. Okay? So I get to x minus 11 halves equals, and now I'm going to simplify this, okay? I'm going to do two things. I'm going to take this 4 and I'm going to take it out of the radical as 2. The square root of 4 is 2 and it stays in the denominator. Now I'm going to take the I out of the square root of negative 3. So I get plus or minus I root 3. Okay? Now I'm going to move my 11 halves, negative 11 halves over, so I get x is equal to 11 halves plus or minus I root 3 over 2. That's an I, so I'm going to do some erasing here because I want to make sure you can see that that's an I. That's an I, and that's a 2. So we're just going to write two answers. X equals 11 halves plus I root 3 over 2, and x equals 11 halves minus I root 3 over 2. And if you wanted to put them all, each of them over one denominator, you could do that as well. We're about to do our last example, and notice that we have an a that is not 1, so we have to divide through by 2. So this new equation becomes x squared plus 5 halves x plus 7 halves equals 0. Make sure you can read that. 5 halves. Okay? Now I'm going to move c to the right, which is my 7 halves, and I get x squared plus 5 halves x equals negative 7 halves. Now I'm going to take half of b and square it. So be careful with this. 5 over 2 squared is, or no, we got to take half of that. See, be careful. Half of 5 over 2 is 5 over 4. And that's what we have to square. So we get x squared plus 5 halves x plus 25 sixteenths. You just square the top, square the bottom, equals negative 7 halves plus 25 sixteenths. Now I've created a perfect square trinomial here. This is a perfect square trinomial. It's very easy to factor. You're going to get x. If you can follow a pattern, you can do this every time. X plus 5/4, and that whole thing squared. Now I have to convert these to the same denominator, so I'm going to multiply 2 by 8 to get 16, and that means I get negative 56 on my numerator plus 25 over 16, and then I'm going to combine that. X plus 5/4 squared equals negative 31 over 16. And now I have to take the square root of both sides. X plus 5/4 squared equals the square root of negative 31 over 16. Notice how your denominator is a perfect square. That's good. Notice how you have a negative under the radical sign, so that means you have an I when you simplify. So I get x plus 5/4 equals, I'm going to do a couple simplifications all at once. The square root of 16 is 4. I'm going to take my I out, so I get plus or minus I root 31 over 4. And so now this one I'm going to write with one common denominator. I get x equals negative 5 plus I root 31 over 4, because they're both with a 4 as a denominator, and then x equals negative 5 minus I root 31 minus I root 31 over 4. All right? Okay, and this is the problem set that we're going to work on in class. Thanks for listening. See you tomorrow.